So basically, we'll be demonstrating Medlock, which is our decentralized application for storing your critical medical data. So this is our front-end interface, which goes as why choose Medlock and how it works, basically the principles that we're abiding by, and also the decentralized method of getting ourselves signed in, also which I'll demonstrate further. So basically, let's log in. So here we are. So this is a secure login powered by blockchain, and we developed it using Web3 authentication. So your details are extremely anonymous. There's no password, nothing. It's purely using your pass ID or rather your public key. So let's sign in as a patient for now. Okay, so here's my MetaMask opening. Okay, so we'll be confirming. So this is a way to authenticate I am a user with a valid wallet address. So here we enter an interface. So this is the way our system works like. So this is a few clinics that as a patient, I'm a part of. So I can have it on my diary listed like this. This is the granted permissions that I'll give my doctor to access my data, which will demonstrate in the next part of the video. And also this is some permissions that I've revoked after granting permissions to the professionals as permitted. So let's go to records. So here, this is how I am hashing my data. So this is actually connected to my interplanetary file system where I'm receiving my hash ID. We'll just do a small demonstration and then it's plugging it into the blockchain. So there's an add record. So we'll just update. Okay. So here's mock data. Fine. So we'll put it here and we'll upload this file. So yeah, it's a success. So from the backend, okay, it's come here. So from the backend, I take my hash ID and I put it in my blockchain. So here it is. So everything's good. So let's now move to the premium feature that our application offers, and that's a chatting application. So here it's for emergency situations and also for consultations. The doctor can access the data using the passkey. So here's a QR code. So for my QR code, my public key was recognized, and now my doctor can just start chatting about my details using my public key. So I can just give a prompt like summarize the details. So, so this is going to return a summary of all my reports, and yeah. Um, Okay, so here's it is. So yes, correct. So the public key that we offered was of the user John Doe, and yes, he was born and okay, his basic details. So we can just extract some more critical information, say his blood sugar. So I'll just ask. Uh, so sorry, there's a typo. Yes. So the details will be dynamically fetched, and yes, that's it. So this is just a small demo of how our model works like. In the next part of the video, we'll see how our blocks treat the raw information and how there is revoking and permission access grant. Thank you. The chat application is basically a premier or exclusive feature for the doctor to understand and quick onboarding and forwarding of the patient as well so that he can quickly determine the patient status and his document referrals. Okay, so this part of the video is basically how the raw blockchain functions, and we'll be querying right from our blocks. So basically first the patient has to register, and I've already done that step, and now he has to upload his CID. So basically it is a hash that is generated from the file that he dynamically puts in the front end in the previous part of the video. So basically that hash can be fetched dynamically, but for now we'll just enter the raw form. So he enters his hash over here and he uploads it. So there's a prompt that will come from the blockchain, and there he goes and he confirms it, and and yes, it's done. So his record is uploaded successfully. You can see these are all his records which he can see, and this is the one which is uploaded right now. So now it's a good to go interface as respect to the patient ID, because there's no pending request from any of his doctors as well. So now we should switch to the doctor's board. So basically we are using a QR based mechanism for the doctor to fetch his patient's ID, but again here we'll just show the raw form. So here goes in the patient's ID, and the doctor will generate a request access telling, I want to see your records for professional causes. So basically this is another prompt that occurs, and he confirms it, and yes, so basically let me just get it confirmed. Yep, done. So okay, I already sent it priorly, so we can just fetch it over here. So basically I'm going to reload this part, and yes, so yeah, so the pending request has come from the doctor's end to the patient. You can just see that there were two transactions, but the first one was considered, second one was neglected. So basically now what the patient sees in his interface is, okay, I see this doctor wants to access, so he will take his public key. Again, it's not going to be the public key, it's going to be the name of the doctor. Here it's a raw form. So he's going to give his approval access because he wants him to see, but there's a duration that will limit the doctor's access. So we'll probably keep it at least 100 seconds for now, and he approves that access, and in the process of approving it, he has to give this prompt. And mind you, the ETH consumed is very minimal in this case, because yeah, the access is approved, so well to go. So now we'll go to the doctor's end, and the doctor will fetch the records, and here you go, he fetches records because he has been given the permission. So now he can view the records that he wants to. Say he wants to view this record, so it will take little time because what copy we are giving him is a redacted copy, so it's not going to be a complete information. So here it's loaded. So basically this is a very basic blood report PDF. So the PDF is converted into a textual format, and we redact the patient's name and all his personal info, which the doctor or any institution shouldn't be aware of. So yes, even the doctor's name, because it could come from some other doctor, is redacted. And yeah, so there are multiple such formats that we have actually fed in here. So there's another copy that can be loaded. So this is how the functionality basically works like. So yeah, this is the other doctor's copy, so the address has been deducted and so on, but this is going to lapse once 100 seconds is over. The patient has an provision of revoking it before time as well. So here I have fed the doctor's ID who is currently accessing it, so we'll just revoke it. So he'll do this prompt, and once he has done this prompt in the blockchain, his access is revoked. So now we'll check out from the doctor's interface, and now if the doctor tries to fetch, he will not be given because of the revoke that's happening, and because he has a prompt of 100 seconds, there is no more. So now again, if I enter the same patient's ID from here, just to check whether the doctor can still access it, he can't, because it's been revoked from the patient side as well as from the patient's end. There's a pending request, we'll reload it, and there's no pending request because it's already been forwarded and treated.